Hi everyone and welcome to my YouTube channel. So we'll be continuing our IMO past problems playlist in which we just solved problem 1 and problem 4. And if you remember, in the previous video we discussed the IMO 1962 which was held in Czechoslovakia. We discussed a nice number theory problem about moving digits, which was problem 1. In this video, of course, we'll be solving problem 4, which is actually a nice and easy, really, trigonometry equation. Actually, one weird thing about this IMO is that it has actually 7 problems instead of 6, which is like the only IMO that has this property. Alright, without further ado, what are we waiting for? Let's get started. Alright, so in this problem, we have the following equation. We need to solve the x equation, like cosine x squared plus cosine 2 of x squared plus cosine 3 of x squared is equal to 1. So as you can see, like this is a poor trigonometry equation in which like we just have cosines and we need somehow to deal with it and simply establish the set of solutions. Alright, so let's start. So as you can see, we have like 3 terms here in the left hand side. Cosine of x squared, this is already a nice thing, cosine x, okay. The next term is cosine 2x. So this thing actually can be simplified because we can calculate it using cosine of x. Like actually in this problem you just need to know some simple cosine formulas, which are really standard ones that you should memorize actually. So for example, we will be using 2 very important ones. The most important thing you need to know is the if you have cosine of x plus y, how can you write it in terms of cosine x and cosine y and sine x and sine y. So let's try this in case you haven't seen it before. So basically cosine of x plus y is equal to cosine of x times cosine of y minus sine of x minus times sine of y. So this is very important formula. You need to memorize this one. And actually cosine of 2x, you can immediately see it from, if you just substitute here, that you can easily see that cosine 2x, if you substitute it here, you can get its cosine x squared minus sine x squared. But guess what? We have here, the first term is just cosine x squared. So why should we put cosine x and sine x? Remember, we can always get rid of the sine by turning it into cosine, especially if you have sine squared. So you can just substitute sine x squared by 1 minus cosine of x squared. So eventually I can just write like this, 2 cosine x squared minus 1. Alright, so this is very good news, because now the next term, the second term, is not cosine 2x squared anymore. Now it's 2 times cosine x squared minus 1, all of it squared. Okay, very good thing. So now we have this. Okay, the next the final term, which is cosine 3x, we can do the same thing. We just need to establish cosine 3x in terms of cosine x. Okay, let's do that by simply of course using the same thing. But here, we'll be doing this cosine 2x plus x. We already know what is cosine 2x, so we can easily see it. So cosine 2x plus x, we just need to apply the formula. 2x cosine x minus sine 2x times sine x. Okay, so now we already know what is cosine 2x, right? It's just 2 cosine x squared minus 1 times cosine x minus 2 times, of course, sine 2x is actually sine, sine 2x is sine x, 2 times sine x times cosine x. So you also actually need to memorize this as well. So it's just now sine x, we can make it squared, times cosine x. Alright. So the same thing here, we have everything is cosine, but we just have a single sine squared. So we can just get rid of it and write it as cosine squared. So like let's just do this. Let me like actually erase like sine x squared, or like let me write it again, no problem, times cosine x minus 2 times, let's take first of all cosine x, and now the sine square is just 1 minus cosine x squared. Alright, let's simplify this. So here like we'll have 2 cosine cube, and here we'll have also positive 2 cosine cube. So indeed like we'll have 4 cosine x cube, and then here we'll have a negative cosine x, and here we'll have negative 2 cosine x, so it will be minus 3 cosine x. Alright, very good. So now we've expressed cosine 3x in terms just of cosine x. But guess what, like I can just like take a common factor here and make it like this, cosine square minus 3. Alright, so now we have like this thing is the third term, but we need of course to square it. Okay, very nice. So now like let's simply substitute everything in the original equation. Cosine x squared, we're gonna keep it as it as it is, and cosine 2x we need to like substitute it from here, and cosine 3x we need to like substitute it from here. Alright, let's just do this. So now we have cosine x squared plus the second one, if you remember, it was 2 cosine x squared minus 1 squared, and finally plus cosine x squared times 4 cosine x squared minus 3, all of it square, and all of this is just equal to 1. Alright, so now we have like this large equation. Let's just take a look at it. As you can see, like our variable is cosine x. Here we have cosine x squared, here we have 2 cosine squared minus 1 squared, and here we have like also cosine x squared, and here we have cosine x squared. So just by looking at this equation, if you want to expand it, we like what is the degree here, like assuming cosine x is the here the variable, you can see clearly that here if you square this, you'll have like cosine to the 4 times cosine squared, so it will be cosine to the 6, right? So it will be degree 6, which is bad. Like we don't want to solve like an equation with the degree 6, right? So instead, let's like take a look. We have here cosine squared, cosine squared, cosine squared, cosine squared. So guess what? Why don't we define a variable like t, for example, or whatever, such that t is cosine squared instead of cosine. So now instead of having an equation with degree 6, now with degree 3, which is like much more easier. Okay, so let's do this actually. So now we'll be substituting. Let t be like cosine x squared, and let's like write the equation in terms of t. Alright, so now it's just t plus 2t minus 1 squared plus t times 4t minus 3 squared is equal to 1. Okay, let's expand this. So of course this will be equation number like degree 3. So first of all we have let's take like write it in order immediately. So we'll be having 16 t cubed. Okay, now what about the squared? Okay, we have minus 2 times 3, okay, minus 24 t squared, and we also like from here we have actually minus 4t squared plus 4t squared. Alright, so it's just minus 20t squared, right? Okay, and next what about the linear term? So now it's plus 90, okay, plus 10t actually, and then minus 4t, so it's plus 60. Alright, very nice. Finally, like what is the constant term here? The constant term is just 1, which is equal to 1. Alright, so now we have, this is our equation, like in terms of t. But guess what? We have a 1 and a 1, we can cancel that. And guess what? Now we have like t here, and it's equal to 0, so we can take a t as a common factor. So guess what? Now we don't have a third degree equation, we have a second degree equation, right? So now like for sure we're done, like we're 100% sure that we can solve this. This is a piece of cake now. Okay, so let's just take t as a common factor, of course divide by 2 immediately. So now the equation is just t times 8t squared minus 10t plus 3 is equal to 0. Alright, let's factorize this. Hope like we can do it without delta. Let's try. Okay, so we're gonna be having like here, this times this will be having 8. So I guess like we need to have 4t and 2t. But here actually we need to have like 1 and 3 or 3 and 1. That depends. Okay, let's try to guess. Okay, first of all, like both of them should be negative signs because they are the same sign, because this is positive and here this is negative, so their sum is negative. So okay, negative, negative. So let's simply like just do choices. 1 and 3, does it work? Clearly no. So it's just 3 and 1. All right, let's check. Here we get 80 squared. Here we get minus 40, and here we get minus 10t exactly. And here we get plus 3. Okay, everything is perfect. Now like we are nearly done. So let's now just write the solutions. So t is equal to either 0 or half or 3/4. All right, so now we found like we solved the equation in terms of t. But remember, t is not your variable. Our variable is what? Is cosine squared, right? So now we need to say that cosine x squared is equal to 0 or half or 3/4. Okay, so what is cosine x? Of course, this is very easy. So cosine of x is now actually these like the squares of these numbers or the negative square roots of these numbers. So we can simply start with the negatives. So we can say negative root 3 over 2, then negative root 2 over 2, then 0, then root 2 over 2, and then root 3 over 2. Alright, so now like we got all our solutions, cosine of x. Nice. Now, of course, we need to find the value of x, not just cosine of x. Okay, so of course, like these numbers, clearly you have like recognized these numbers. Like this is the cosine of what? The cosine of pi over 6, right? Or like 30 degrees. This is 45 degrees, or like pi over 4. This is pi over 2. And these are like the negatives, so you can easily like know what are these. So let's just write this. So cosine x is just equal to, okay, so this one here is cosine pi over 6. This one is cosine pi over 4. This one is cosine pi over 2. Okay, what about this? Well, this is just cosine, like pi. Okay, like imagine you have the unit circle and you have the cosine here. This is the cosine. So if you know that this has cosine, like this is cosine pi over 6, right? If you take this one here, this will be like the negative value for it, right? So how can we get this? This is just actually the angle of this is just pi minus this angle. So it's pi minus pi over 6, right? Okay, so here like we can just write cosine pi minus pi over 6, which is just like 5 pi over 6. What about here? Like here we also have cosine of 3 pi over 4. Okay, so now like we got simply like what the cosine of x is equal to some bunch of cosines. So how can we know the value of x, right? Because remember, if you know, if you have like an equation like this, cosine of x equals cosine of theta, that doesn't mean x is equal to like theta immediately, because we are dealing with trigonometry, right? So we have like a certain shape we need like to add, for example, multiples of pi or 2 pi or stuff like that. All right, so like one idea here is just to draw a unit circle and put these numbers there, and then like try to imagine how can we get like the set of solutions. Okay, so let's do this actually. So let me just draw a unit circle. Okay, let's take here the cosine, and let's take also the sine as well. Okay, so now we have pi over 6 right here. Let's say we have pi over 4 here. This is like pi over 2 already. And we have also like this one here, 3 pi over 4, and we have this one here. Okay, so like these are the angles that we have put here. But of course, if you know like cosine, like if you know cosine x is equal to cosine of theta, then x is equal to theta or x is equal to negative theta, right? Because if you remember, cosine of negative x is equal to cosine of x. Cosine is even function. So not just these like we have here, we also can flip them over the x-axis or cosine axis, which means like now actually you just have this, this, and this. Of course, like if you have the pi over 2, then you also have negative pi over 2. So if you like have this, then you have this as well. Okay, of course, you like these are the solutions, and then we just need to add 2 pi's to them. So actually like we're done right now, but we can like write the solutions in a more beautiful way. So how exactly can we write them in a more beautiful way? Let's take a look here. So first of all, this is like here pi over 6, and this is pi over 4. This is of course like pi over 2, and so on. So let's take a look at pi over 4. So we have pi over 4, that's it. Here we have pi over 4. Here we have pi over 2. Here we have 3 pi over 4. But we don't have 4 times pi over 4. So we have pi over 4. We have 2 times pi over 4. We have 3 times pi over 4. We don't have 4 times pi over 4. And of course, like the same thing, if you like keep going like this. So what can we simply say? We can simply say that we have pi over 4 times some number. This number can be odd, right? So 2k plus 1. This will indeed like give us the pi over 4, 3 pi over 4, 5 pi over 4, which is like here, and so on. Okay, this is very good. Also we have, remember, pi over 2 and the multiples of it. So we can say, also we have pi over 2 times, but of course not even numbers, times odd numbers. Okay, so now like we're done with the pi over 4, pi over 2, and this stuff. Now we just have pi over 6 and 5 pi over 6. Okay, but this is also like easy to handle here. So this is pi over 6 here. Take a look here. You have pi over 6, you also have this, right? Which is just like pi over 6 plus pi. So we can simply say we have pi over 6 plus like just multiple of pi's, right? So we can simply say like pi over 6 plus like multiples of pi. So what is exactly this? It's just like actually 6k plus 1 pi over 6. In the same way, we can do like the same thing for 5 pi over 6. Take a look here. This is 5 pi over 6. We also have like the whole extension here. So we also have like 5 pi over 6, and we can add multiples of pi. So the same thing exactly, like 5 pi over 6 plus k times pi. You can take pi as a common factor and like make it more clean. So it's just 6k plus 5 times pi over 6. And guess what? These are all our solutions. We've like established all the set of solutions. You can just put k any integer and it will generate to you like the solutions. So these are actually the set of solutions, of course, for any k an integer. So that simply was the question, like a quick revision for it. We started with simply this trigonometric equation. We tried to simplify it a bit by a bit. We turned it into like a variable t, and finally we got the values of t, and then like we established it again and again until we reached out like the final thing, which is the set of solutions in a nice way. Alright, so that was it for this IMO 1962. As you can see, this question was really easy. You just like need to do like the simple algorithm, like you have cosines, like cosine x, we keep it, cosine 2x, we need to write it in terms of cosine x, cosine 3x, we need to like write it in terms of cosine x. Then you get like an equation, 6-degree equation. Of course, like just a simple trick, very standard. You just like put a variable t, that's cosine squared. So now you have simply a 3rd-degree equation. You can easily solve it, like factor actually. He factorize, it's very easy. And then like we can get back to cosine of x squared, then cosine x, and eventually find the values of x in a nice way. Alright, so that was it for this IMO. In the next video, we'll be moving on to the next IMO, IMO 1963, and hopefully like we'll be continuing in this series. So I hope you guys enjoyed this video. Please like, share, and subscribe to the channel, and see you guys in the next video.